All right, so this video is going to cover both 3-3 and 3-4, so dividing and factoring and the factor theorem. So question number 1 on 3-3 says, a rectangular prism has a volume of blah, 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 and a height of 2x plus 1. So it says find the area of the prism, and it kind of gives you a little formula here. So I just need you to kind of take a second and realize that if this is the volume, then that's going to represent this V, okay? And then we're trying to find the base. No. Yes. Yes, the area of the base. So it says find the area of the base right here. And then we are going to substitute this right here. So if I wanted to find the area of the base, what I would need to do is I would need to divide both sides by h, correct? So that means I'm going to use volume divided by the height equals base. So this is a division problem. That's why it's in less than 3-3. So the volume is going to be 8x to the third plus 14x squared plus x minus 2. And we're going to divide that by 2x plus 1. So to divide, we are going to create 2 rows. And if I'm dividing, I kind of leave this open. I don't know how many boxes I'm going to use. But I do know that this first category right here is going to be 8x to the third. I'm going to work backwards. That'll be 4x squared, and then I can multiply to be 4x squared. Okay, here's the trick. Next column. These two right here have to add up to be the quadratic term. So 4 plus what gives you 14? Oh, well, that'd be 10. Okay. Keep working backwards. So that's going to give me 5x here, multiply by 1, 5x. We've got another diagonal, which means that that has to add up to be our linear term. 5 plus what gives me 1? That means this is going to have to be negative 4x. Work backwards. So that'll be negative 2. And if I've done everything right, this should match this right here. And I know that I've done it right because if it's, you know, just the sides of a rectangular prism, there shouldn't be any remainder, nothing left over. So it's a simple division problem. My answer should be right here. So 4x squared plus 5x minus 2 is my final answer. Okay, so the next part is going to be lesson 3-4, which is factoring and the factor theorem. And I'm just going to be honest with you. I'm going to show you the quickest, most straightforward way to do these problems. You can always use the box method. That will work every single time. But some of these, I'm just going to use the quickest way to do it. For example, number 1, this is a difference of squares. I recognize it as a difference of squares, so I'm going to go ahead and write them as squares, which is really important, okay? So if this is x and this is 6, that straight up tells me that my two factors are going to be plus 6 and minus 6, okay? If you wanted to do the box method, you absolutely can do that. You would need to find the factors of negative 36 that add up to be 0 because there is not a linear term, which is, guess what? 6 and negative 6. And if a is 1, which it is in this case, you don't need to use the box. So that is absolutely the fastest way to do your difference of squares, okay? Let's look at, nope, that's 3. Let's look at number 2. So this one is a greatest common factor and a trinomial problem. So I noticed that they all have zeros and they all have an x. So I'm going to factor out 10x. All right, so most of the time in Algebra 2, if it has a GCF, you can continue to factor. We've done several of these. So if you have a trinomial, you need to go ahead and find the factors of 7 that add up to be 8. Take a little note right here that a is equal to 1. If a is equal to 1, you don't need to use the box, all right? So it looks like I'm going to use plus 7 and plus 1. Since you don't need to use the box, you can just go straight into it. You're going to use plus 1 and plus 7. Plus 1 and plus 7. Drop your GCF down. Final answer. Done. Let's look at question 3. So question 3, it's got 4 terms. Always look for a GCF. This one doesn't have a GCF. So I'm going to immediately create a 2x2. Yes, it is faster, in my opinion, to create a box method or use box method, and we're going to use a 2x2. The reason why I like this is because I can easily figure out a GCF of each one of these rows, which is x squared and -9. And then I can work backwards. So that would be x, and this is going to be -2. So my first go would be x squared minus 9 and x minus 2. So if you're not quite the best at recognizing patterns, you may get this far and then kind of stop. But I want you to notice that this is factorable again. So that is a difference of squares. So that's x squared minus 3 squared, and you can continue this difference of squares pattern by using +3 and -3. Just don't forget to drop the x minus 2 here. All right, last one in this little part right here is number 4. Always look for a GCF, always, 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 and it has one. So I can divide both of them by 8. So that leaves me with x to the third minus 8. Once again, double check to see if you can factor this. This is a cube pattern, and if you think you can write it, you need to try, and yes, I can. So if you can write it, that basically tells you that x minus 2 is a factor. You just need to find whatever is left over. Don't forget to drop your 8 here. Okay, so if you can write it in this cube pattern, that means you can divide it by x minus 2. Okay, we got to set it up, and we're going to start with, now remember, I'm factoring this, okay? So I'm going to start with x to the third, and it should wind up with a -8 here. Okay, working backwards, x squared, multiply. These two have to add up to be nothing because you don't have a quadratic term. So opposite. Work backwards. Multiply. These have to add up to be nothing because you don't have a linear term. So that's going to be positive 4x. Now if we've done it right, yes. Okay. So this part right here is going to be multiplied times x minus 2, x squared plus 2x plus 4, and that is our final answer because we're just factoring. So question number 5 is also going to be a factoring problem because it's giving you the total volume and you're wanting to work backwards to find the dimensions. So you know volume is length times width times height, so this is going to actually wind up factoring twice. And you'll see that here in a second. So if I wanted to factor 4 terms, I'm going to go ahead and do the 2x2. Set it up. Make sure you're writing it in standard form. Okay, if I find the greatest common factor of each row, I get x squared and minus 4. If I work backwards, I get x and -8. So what happens is that you can rewrite this volume into x squared minus 4 times x minus 8. Now, that's not 3 different factors. It's because this is factorable again. That's a difference of squares. So you can rewrite that as x squared minus 2 squared. And there we have it. It's x plus 2, x minus 2. And then just drop this one down. Length, width, height, whatever order you want to write them in, those are your dimensions that you're looking for. So the last question is a factor theorem question. Basically, it's asking you if x plus 2 is a possible factor. So if it's a possible factor, you're going to want to test -2. If you just plug that in to your function, just make sure that you're using parentheses. Your result is 0. That means that your remainder is 0, and if you have a remainder of 0, that means that it is absolutely yes, it is a factor, and you also know that -2 is a solution.